Good day, guys. This is your tutor engineer. We are continuing with our series on geometry. Let's start with today's lesson. In the figure below, point B lies on the line PQ. ABCD is a rectangle where A, C, and D lie on the axis. DC is equal to K. The first question is determine the length of BC in terms of K. Okay, now let's do the length for BC in terms of K. What do we have? We don't have the coordinates at B at this point, so let's just call the coordinate here as K, and then the y coordinate will be from the axis all the way up. It's going to be BC itself. Okay, let's just maximize. Okay, let's just maximize a bit so that we'll be able to see. Now, okay, let's calculate the slope. Since you know that we have been given the coordinates of P and the coordinates of Q, let's first calculate the slope for PQ, which will be the same as the slope for BQ. That's the first thing we may start to do. Okay, let's do so. The gradient for PQ will say YP minus YQ divided by XP minus XQ. So it will be equal to YP is 12, so say 12 minus 0. And then XP is 0 minus 6. 0 minus 6, that will be 12 divided by minus 6. The gradient is minus 2. So you must notice that this will be the same as the gradient for MBQ, since it's the same straight line. So we know that the gradient for MBQ, we can also rewrite it as y at B minus y at Q divided by x at B minus x at Q. So we said all of that will be minus 2. So okay, y at B will be BC, right? So we'll say BC minus 0, and then x at B will be K. We'll say K minus 6 is equal to minus 2. So this can simplify as BC divided by K minus 2. Sorry, K minus 6 will be equal to minus 2. So meaning BC will be equal to minus 2 multiplied by K minus 6. So we can further simplify this if you want as BC is equal to minus 2K plus 12. Okay, so this is the answer for question 1. Then for question 2, determine the coordinates of B for which A, B, C, D is a maximum area. So here is A, B, C, D, this rectangle here. So remember, when they talk about maximum area, you must start thinking about working out the derivative. Firstly, the area for A, B, C, D will be, remember, this is a rectangle, and then this distance here will be the base. It's equal to K, and then our height will be BC, right? So our height will be BC. Okay, let's calculate the area. It's base times height, and then we'll say our base is K, our height is BC, Since we've already worked out BC in terms of K, we'll just replace BC by minus 2K plus 12. Then you'll have minus 2K squared plus 12K. So this is the area, right? So this is the area of ABCD in terms of K. Since now they're looking for the maximum area, we must work out the coordinates of B, for which the area has the maximum, for which the area would be maximum. Now let's get a derivative. Then the derivative will be 2 times 2k plus 12. Derivative is minus 4k plus 12. So that's the derivative for k. We'll set the derivative to 0 to get the maximum area, since that will be a peak. And then we'll solve for k. We'll have 4k is equal to minus 12. K will be dividing by minus 4 both sides. We'll get k as equal to 3. Now let's work out the coordinates of B. You've already written out the coordinates of B. Let's just now simplify. Since k is 3, we just replace k by 3, and then BC, we set BC, this was the value for BC, sorry, this was the general formula for BC, so we'll say BC, by replacing k plus 3, we'll be able to get minus 6 plus 12, which will be 6. So the coordinates for B, for which the area is maximum, is going to be 3 and 6. Now let's do question 3. Determine the maximum area for ABCD. Okay, we've already worked out the formula of the area. This is the formula of the area in terms of K. Now let's replace K by 3, since it's the maximum area. Where K is 3, the area will be maximum. So 5.3 will say, first write out the general formula for the A, and then we'll replace K by 3. Then here we'll get minus 2 times 9 plus 36 minus 18 plus 36 will be equal to 18. So since we've not been given the units, we can say square units, 18 square units. Okay, we'll end here. If you liked today's lesson, please subscribe and stay tuned on the next lesson on geometry. Cheers.